Assalamualaikum and welcome to my YouTube channel. So in this video we will gonna analyze a simple roof truss in Etabs 2021. So it is the continuity of the Etabs series which was started from the analysis of a simply supported beam, and it will go on through different phases, and at the end we will end up analyzing a 15 or 10 story building. So keep connected with me, and if you like the video please subscribe the channel and share it. So now first of all we will open a new file by going to file, new model, or clicking Ctrl N. After opening the new model we have three options. So we are at a basic level, so we will start with the default settings, and after setting this, now it is asking for the grid spacing and story dimensions. So for the analysis of a truss, since we know that in the e tabs the z direction is in vertical, and in the horizontal plane x and y axis long lay in the x and y plane, and the z-axis lies in the vertical plane. In the horizontal plane only two axes, x and y axis lane. So in this uh, software, for the analysis of truss or frames, we will use our z-axis as our y-axis. I will show you later how. So we will be analyzing this truss in our this video. So if you see that we have a simple truss which contains 4 point loads and total span of 6 meter and 2 meter height. So if you see that we have only one story, this is your 1 point and this is your second point, so we have only one story of 2 meter height in the z direction, vertical direction, and in the horizontal direction it contains 6 meter span. So first of all we will be going and selecting our number of grid lines and symbol story data. For our story data we have only one story data, and for the number of grid lines in x direction, if we see in the x direction there is 1, 2, 3, 4 grid lines in the x direction. Four grid lines, number of grid lines in x direction are 4, and number of grid lines in y direction will be 1. Why? I will let you know in a minute. So we will change the spacing when in the click. Now we will click OK, and we have three windows open. First, model explorer window 1 and window 2. It gives us the 2D view and it gives us the 3D view. Now first of all we will change the units, as our units are in kilonewton and meter, so our units are changed into metric SI units. Now I have told you that our in etabs our horizontal plane lies contains only two axes, x-axis and y-axis, and our vertical plane contains z-axis. So for drawing vertical components we will use x and z-axis and ignore y-axis. So it is the reason that we have considered only one line grid line in the y-axis, and considered one story in z-axis, and four grid lines in the x-axis. Now first of all I have changed my units. Now I will go to the grid system and adjust the spacing also. So if I came here to the story data, so I will change my story height to 2 meters, since the height of my story, the height of my truss is 2 meter. And now I will go to the grid system, and opening the grid system, first of all I know that I want to have four grid lines of spacing 2 meter. So I will simply modify it to 2 meter, and after modifying it to 2 meter I will simply press OK. Now I will change my elevation view to, now I have my elevation view in x and y axis. For example I am looking for the top, but I want to locate from the front elevation. So I will just go here and click on y axis or 1 and click on OK. Now you see that I have the grid lines where I can make my uh, truss. So seeing on the truss structure, we will try to make the truss. So we will came here and click on draw, and just simply draw our truss. So I am going to draw my truss. So there is a special point which we must consider in the analysis of the truss. Otherwise, our truss will be wrong. Analysis will be wrong. So I will tell you in the later portion of this video. So please don't skip the video. It is an important instruction for you as well. So I am drawing my truss. It's almost been drawn. Here you should must consider that these two portions are separate portions. Do not combine them in a single portion. So now I will simply draw these two lines also. So my truss structure has been drawn. Now we will check our support reaction. So at A point we have the hinge support, roller support, and at D point we have the hinge support. So here we have the roller support. We will click on this point and will go to assign joint and restraints and will assign roller support here and will assign no supports here, and here I have click on apply and apply no support here and click on OK. So I have hinge support here, roller support here, and no supports at here. Now we will apply the loads. So we have 4 point loads: 25, 10, 15, and 20 kilonewton. So first of all, you should know that this point that in the truss we only apply load at the joints. So for applying loads, we will go to the joint loads and force. Now I wanted to apply a load here which is of 25 kilonewton. So z axis is in top direction, we will write it in minus. So I have applied it. I wanted to apply, I think so, minus 10 kilonewton. Sorry, I have to select and now apply. And here I will apply minus 15 kilonewton, and here I will apply minus 20 kilonewton. Now you see that I have applied my all the point loads on the structure. All the 4 point loads are applied. Now what is things are remaining? We have applied the load, we have assigned the restraints. Now the important things which we must consider while analysis of a truss are that is that for the truss we assume that all the connections of the truss are pin connection, means there is no movement in the at these connections, and actually there is movement but it is of very small value, so we consider it as negligible for our easiness. So for applying this condition on this truss, we will select whole the truss, and after selecting whole the truss I will go to assign frame and release or partial fixity. Here we will make all the movements to the zero. We are applying the condition, the assumption that all the truss joints are pin connected, and apply and OK. After applying this condition, now our truss is ready for analysis. But since our analysis we do not consider the self weight of the structure, so we will make the self weight of the structure to 0. We will come to assign frame and property modifiers. Here I will make the mass equal to 0 and the weight equal to 0, and now I will simply apply it, and after applying it I will simple press OK, and now my truss is ready for the analysis. So I can go to analyze and check model and select this all and press OK. So it is checking my model either is there any problems with it in drawing it or any other complexities. So it has checked that model has been checked and no warning messages were generated. Now we will run the analysis. I will save it as 6 channel name, and my file is now saved. And after saving my file, you can see that it is running the analysis. It will take a little time, and after completing it, still it is analyzing. It takes 1 minute, so you should be patient. So it is almost completed. So must you must consider for the assumptions in it, that either the truss will be all the joints of the truss are pin connected and the moment is zero, and only the you should know that there are no moments or shear forces in the truss. We only consider axial forces, as truss is a axially loaded member. We have only tensile or compressive force in the case of trusses. So it is just a warning message that we have make the sulfate of the structure has zero. So it is no, it does not contain any other concern. So this you can see that here it is deform shaped. You can see now I click here and check its reaction, that what are its reactions. So I have only reactions in the x and y direction, and you can see we have only got the reaction in 50 and 20. And for checking our analysis, we can check that you can see that total reactions it got was 50 and one was 20 kilonewton, 50 and 20 kilonewton, which we got in the uh, slide. Now if we check out the forces here, it has found find three forces: FGF, force in this member, force in this member, force in this member. So the forces came out to be 7.07, 25 and 20. 25 is tensile and other two forces are compressive. So I will come to my etabs and check what are the forces in this member. So you can come here to SFD, where you check your SFD. Now you only consider axial force and click on show values and apply, and you can see that it has find out the forces, and it has find minus 20 here, minus 7.0 compressive force here, and 25 as tensile force here. So these are the same forces as it has found by manual calculations in this truss in these members. So this was the analysis of the truss. So at the end, I would suggest you to remember the assumption that at the truss all joints are pin connected, and in the truss we have only the axial forces, no shear force or bend movements. Actually there is movement, but it is a negligible value, so can neglect it. I hope you will like the video, and if you like the video, please subscribe my channel and share it, and stay connected with me for more further ETAB videos.